Hello, everyone. My name is Aurelio Muraca. I'm the Technology Program Coordinator here at the Danbury Library, and I welcome you to our Series 2 of Earth in Crisis. This is our third episode with Dr. Mitch Wagener of Western Connecticut State University. And tonight's presentation will be climate change in Connecticut. I know this is a hot topic for a lot of folks, and without further ado, Dr. Mitch Wagener, you have the con, sir.
Thank you for coming out, everyone. I appreciate you making the effort. I'll just start off by saying, let's see, I can share it. Hang on just a second. Let me pull up my slides and really you can tell me whether we're seeing them or not. Can you see the science building?
No, I do not.
Okay, so I'm obviously not pushing the right button in the right way. Oh, there we go. There we go. That should do it. Now do you see the science building?
Yes, I do.
Okay, pardon me, I've got a little bit of allergy issue. I'll try not to cough in the microphone as best I can. Let me just give everyone a little bit of a refresher on the definition, the differences between climate and weather. Okay, I never know exactly how many people have seen some of the other talks I've given or other related topics. By the way, I was getting ready to say this is my 175th public talk on climate change since 2008. So only because it's a round number do I bring it up. I'm looking forward to being able to say 200 at some point this year, I hope. So we'll see. Climate and weather are kind of two flip sides of the same thing. Just people get them confused sometimes. You'll hear someone look out the window and say, how can you say it's the world is warming? It's cold out there, which is a legitimate observation. But the thing is that climate and weather are like two ways of looking at the same thing. Okay, climate is temperature and humidity and atmospheric pressure and wind and rainfall and all these things that we hear from on the weather station or on the weather channel. But they are, we observe them over a long period of time over a large area. It's a large scale look at those things. Whereas weather is what you see when you look out the window. It's what's happening in a small scale in a small area over a short period of time. Okay, so we can know we have a pretty good idea of what the climate was in Connecticut 16,000 years ago as the ice began to melt, okay, at the end of the ice age. We cannot know what the weather was like on January 30th, 16,000 years ago. Okay, so they're a little different things, but they are related. Okay, let's see here. All right, so climate's what you expect and weather's what you get. Now, also, just to remind you that climate change is not just seen as a matter of temperature, okay, but it's lots of things, and they're related in that they're all related to the buildup of heat in the atmosphere. However, they are measured in different ways by different people. You do not use one of these measurements to calculate the others, so they are independent variables. Scientists will argue about how these things should be done correctly and how we should treat the data and all that. And all that arguing back and forth among the scientists is a good thing, because that helps us to correct errors that might creep in and come up with the best way of looking at this material. And climate change isn't just meteorology. It's not just temperature and moisture. It's also how organisms of the world react to it. Okay, how the earlier warming on average of the spring, on average, not every year is the same, how that affects the blooming of the flowers and the arrival of birds and what insects are out and all that sort of stuff. I like to be, maybe because did my graduate work in Alaska and I spent a lot of years up there. I am always interested in the ice. And so I like to follow what's happening with the ice, because if the ice were not melting year after year after year, I mean, if the world were not warming year after year, we wouldn't see ice melting year after year. So it's kind of the big thermometer for us to take a look at. And there are some papers that just came out by this fellow named Ripple, 3 or 4 new papers that basically put numbers to all those little arrows in the previous slide, showing the carbon dioxide, CO2 parts per million on the upper left, and methane and nitrous oxide, and all these things that people talk about in terms of climate change. We have data to show that they're actually happening, and it's not just an arrow. Okay, so the arrows are represented by data, and the arrow is just the summary. All right, let's see. All right, now I'm going to talk about these seven things associated with climate change, and some of them are an issue in Connecticut, some of them are not, but related things are, and some, we're not like living in Southern Florida. There are certain things which are not going to be as much of an issue, but there are other things that will. And so we'll sort this out. And so you get a general idea of what Connecticut, our small state, can expect. Well, one of those is chaotic weather. And by chaotic weather, we mean weather that changes rapidly and sometimes surprises us. This is brand new data. This is the 2022 average temperature, where it is applied to the map, and the color of the map, or the part of the map, indicates how much warmer or cooler the weather was on that location in comparison to the 30-year average from 1981 to 2010. Ignore the big thing that says 1951 to 80. That's my mistake. I should have gotten rid of that. In the top, it says 1981 through 2010. 30 years of information is kind of how we judge, how we decide how much information we need in order to say something about what's going on with the climate. And so, for instance, if we look at the weather in southern Greenland, in the big island to the north of both Europe and eastern United States, we see that parts of that were very warm, and they were between 2 and 3 degrees warmer last year in comparison to the average at that spot from 1981 to 2010 for that 30-year average. Okay, so you can see whether the fact that you felt particularly warm or particularly cold last year, whether that really reflects a comparison to a 30-year average or not. Scientists collect data and analyze it because sometimes our personal anecdotes and what we remember happening aren't as accurate as we'd like to think they are. And so this gives us a chance to give us adequate comparisons. Well, what you can see here is that there are some areas that were cooler than that average. Australia, for instance, at least most of it, was a bit cooler than 1981 through 2010. The northern tier of the United States, the southern tier of Canada, you can see is blue, parts of Brazil. You'll also see that off the Pacific Ocean to the west, Peru and Chile is pretty blue. That's indicative. That is what we would expect during a La Nina condition. La Nina conditions are kind of a exaggerated version of the average condition. And so we typically would expect to see cool water in the eastern part of the Pacific, for instance. All right. You also see that there's a lot of area around the world, some out to sea, some in Antarctica, which is kind of distressing, and Greenland and northern Russia, which were really warm this last year. We'll have to see how things turn out because we are probably shifting into an El Nino condition few years. And El Ninos are typically warmer than the trend, while La Ninas are typically cooler than the trend. The global average temperature has been climbing. It hasn't been climbing every year warmer than the next because that's just not the way things work. But the trend is pretty clear. And one thing we can see here, the last 3 years were La Ninas, which are supposed to be cooler than the trend. And yet they were 3 very warm years. And altogether, the last 7 or 8 years, last 8 years are the warmest 8 years in history since 1800. Okay, so that's a concern, and that's during a time where we would expect it to be a little cooler than the trend. And you can see with this map of the ocean that specifically zeroes in on the ocean where the warm bits were in the ocean and the Atlantic coast off the coast of, or Atlantic off the coast of eastern United States was pretty warm, as was parts of the South Pacific and parts of the northern Pacific as well. Now, I said that El Nino basically influences those patterns. Okay, El Nino is, well, let me back up. The average condition, the normal condition. When a scientist says normal, he means average. The normal condition, the most common one is for there in the South Pacific to be a high pressure over, say, Tahiti in the South Pacific, a low pressure system over New Guinea. And that the high pressure causes wind to flow from high pressure to low pressure. And as it does, it makes that current, which is the natural current flow or the average current flow in that area, to be east to west. And that pulls cool, nutrient-rich water up from Antarctica, which enriches the fisheries and the Peruvian anchoveta and the sardines and other things that are down there are abundant in those years in general. Every so often, the high and low pressure system reverse, and so that the low pressure system will be over Tahiti and the high pressure system will be over New Guinea, and the winds will reverse or at least weaken considerably, and that is an El Nino. And that means that there is less cool water coming up from New Guinea or from Antarctica, and that weakens a lot of other currents in the Pacific, which, strange as it may seem, really changes around weather patterns across the world. We have more hurricanes during an El Nino than we do a La Nina. Sometimes after an El Nino, the conditions will go past normal into kind of super normal for a few years, and that's what a La Nina is. Okay, so you'll hear more of that when scientists talk about something called ENSO, E-N-S-O, as you can see in the in figure 14 caption here. That's just initials for El Nino Southern Oscillation, which is the overall phenomenon. And scientists have a way of quantifying it to see how strong the El Nino or La Nina conditions are and so on. It's something that's we realize is a very important thing to weather conditions around the world and hurricanes. And so we track it and keep track of it. Now, in the 48 states, as Alaskans, you typically say the lower 48, which is the states with the exception of Hawaii and Alaska. The average precipitation is to have the eastern part of the 48 states wet, and the western part pretty dry. Okay, that's what's considered to be the usual condition. We're seeing some real weird stuff now because we have those atmospheric rivers bringing lots of moisture into California and so on. Following some crazy droughts, and so it's been a rough few years for people in some parts of California, having to go from very dry to very wet in a very short amount of time. This is what we typically expect if you've lived in Connecticut very long, and I've been here, what, 27 years. You know that it's a fairly moist state. There's a fair bit of rain here, generally speaking. Now, one of the other things, but the chaotic weather, really, I'm referring to the fact that we're likely to see weather flip-flop back and forth between really dry and really wet, really hot and really cold, more rapid than is normal, that is usual for us, and we'll see it going to more extremes in that sort of flip-flop than we've seen in the past. Okay. One of the topics that is one of the facets of climate change that is a big deal to much of the world is sea level rise. There's two ways in which the sea level rises more or less permanently. I mean, you can have a hurricane come in and temporarily raise the sea level on a local level, but when the hurricane's gone, the sea level goes back to the way it was before the storm. But more or less permanently, at least in the time scale that humans are used to thinking about them, the ways that sea level rises is if water is added to the ocean by melting of ice that's perched up on land, or melting of that ice on land and the water running into the ocean. So both of them will increase the amount of water in the ocean, therefore the sea level goes up. Okay, that's one. The other is just heating the water. If you remember high school chemistry, you might have had this in high school chemistry, is when you heat water, the water molecules get more energetic and they want to be farther apart from each other. Therefore, the water takes more space. And that's something you can prove in your own kitchen if you wish to see it with your own eyes. And sea level rise is an issue. In some parts of the world, it's a terrible danger, including, some parts of Thailand where I lived when I was in high school, and Shanghai is one of the most dangerous places because it's right at sea level, but there's so many people living there. So a sea level rise there would be pretty serious for them. And some parts of the United States, the eastern coast, particularly Florida, Louisiana, and the southern coast is pretty low lying near the coast, and so there's a lot of areas currently above water which will be below water by the time my grandson grows up. Connecticut, we have a little bit of shelter. We have a little shelter from the fact of our topography. We're hilly, and we don't have as much low-lying land right next to the shore, and we have a little bit of shelter from Long Island being there as a barrier island for us. There is some area, especially in the Connecticut River Valley, that's pretty low elevation and subject to flooding potentially. Sea level rise is not going to be as big a deal as some of the other things for Connecticut in general. That doesn't mean we won't have flooding. And I'll give you a good example of that here in a bit. Yeah, there we go. Well, one of the things that can cause us to flood is storms. This is Sandy, I believe, although it's hard to tell one hurricane from the other from this point of view. No, it isn't Sandy. Sandy came up over Cuba. And but nonetheless, we have these big cyclonic storms that gain their hurricanes. They gain their power by as they move across warm water. So the warmer the water, the stronger the hurricane. Okay. We also have other cyclonic storms called nor'easters, which we'll talk about in a minute, that are not fueled quite that way. They're fueled from the contrast in temperature between the air on land and the air out to sea. Okay. And the difference there is what gives them pep, so to speak. We have both of them, as we all know, and at least in one instance, we had a kind of a combination, and that was Sandy, which we'll talk about in a minute. This was a aerial photograph looking down into the eye of Sandy, which is beautiful if you didn't didn't think about how much damage she caused. This is the point at which the hurricane spins, and it is a point of low pressure. And it's beautiful and terrible all at the same time to see it. So Superstorm Sandy, so-called, was in 2012. I was here, I remember it. It peaked as a Category 3. There's this scale we use to estimate the relative size and strength of a hurricane. But basically, that particular scale just judges the wind speed. It doesn't take into consideration the amount of water that's moved and pushed up on shore. Because that's what a lot of the hurricanes damage can come from, is storm surge. The scale runs from, well, if it's below a certain level, it's a tropical storm, and then a tropical depression, and so on. But the hurricanes are listed from Category 1 through Category 5, and there are there's some conversation about putting on a Category 6. There's also some consideration of developing a new index that actually includes water damage in the category system. Sandy would peaked at Category 3, but most of the damage caused was in when she was a Category 1, and that is because of all the water she moved. And she came right over the top of Jamaica and eastern Cuba and up through the Bahamas, and then was tracking up the coast. And then for reasons of her own, she turned left and made a beeline for New Jersey. At Brigantine, New Jersey, October 29th, it was a post-tropical storm. Winds were 80 miles an hour, which is enough for a Category 1, but at this point, Sandy was not exactly a hurricane because there had been a nor'easter there too, and they kind of combined together and formed something else again, something that had characteristics of both a hurricane and a nor'easter. There were 72 direct deaths, at least 87 indirect. U.S. damage estimates were $50 billion in 24 states. And some of that damage coming in areas where there wasn't actually the hurricane didn't track over. Hang on, let me kill the phone. Sorry about that. It's an old phone and I can't figure out how to turn the volume down on it. In Connecticut, we had damage too, although nothing like what they had in New Jersey. Sewage backups, pollution caused by seawater churn up by Sandy, knocked out power for 600,000 people throughout the state. That's a mistake, 4 people, including a firefighter from Easton, were killed. Tragically, damage amounted to about $360 million in damage. Significant storm. Trying to talk my wife into getting rid of that phone, but I haven't talked her into it yet. Someone once asked a noted climatologist at the time, Kevin Krenberth, who works at the National Center of Atmospheric Research, to what degree the damage of Sandy was because of climate change. And his answer was this, and it's classic. The answer to the oft-asked question of whether an event is caused by climate change is that it is the wrong question. All weather events are affected by climate change because the environment in which they occur is warmer and moister than it used to be. Okay, so that's the way to think about it, that we can expect storms, hurricanes and snowstorms and nor'easters and whatnot, tornadoes, to be stronger than they would have been in a drier, cooler world. Okay. Although it's difficult to compare the contingency of one particular storm, what it would have been like under different conditions. Now, what's a nor'easter? Well, you know, if I talk to people in other parts of the country and you say nor'easter, they don't know what the hell I'm talking about. It seems to be something that is from the northeast, and hence the name. Nor'easter is a cyclonic storm that can occur in cooler weather, as we know. They are not, you know, specific to summer and early fall like hurricanes tend to be. They are what are called cold core hurricane or cyclones, and they get their energy from the contrast of temperatures from the cold air on land and the warm air out to sea. And so it's not just the warm water they're getting, but the contrast. And so the higher the contrast, the stronger the nor'easter. And they get their name from the fact that they will line up along the coast. Unplug the damn thing. Okay, so they get their name from the fact that they will come up the coast and they are pulling moist air from the ocean, and it's warm and it's coming in contact with the cold air on land, and it causes precipitation, lots of it. Okay, so that that the weather is coming in from the northeast often, hence the name. And so what nor'easters typically do is to park themselves right offshore and then dump lots of precipitation on us. All right, so that's a storm that people back in Missouri, where I grew up, don't have to deal with. Now, another thing that we might expect is episodes of extreme heat. After all, the world is warmer than it's ever been in the past. It is, or in the last 120 years anyway. And it is continuing to warm, and we don't see a lot of chance of that changing in the near term. One of the episodes that we need to be on the lookout for is something that may happen in warmer climes, but it could still possibly happen here. And this is something called a wet bulb event. A wet bulb event is caused by a combination of relative humidity, 100%, combined with a temperature of 95 degrees Fahrenheit or 35 degrees Celsius. Okay. And you put those two together and you have conditions that are extremely hot, but they exceed the human body's ability to deal with. Okay. For instance, if you put a young person in the shade with the fan on them, buck naked with all the water they can drink at combination of 100 degrees relative humidity and 35 degrees temperature, you're going to have heat stress and the possibility of that person succumbing and dying. Okay, so it's possible that we could have temperatures and humidity that would achieve that level here. Okay, last summer, in fact, there was a really hot snap with quite humid conditions being forecast, and the problem was, or the thing was, that we lucked out because the humidity didn't really materialize as bad as it could have. And so these sorts of conditions can be a big problem, especially in those areas of the world where the electrical supply is not reliable, or areas of the world where they just don't have air conditioning available. And you could have a wet bulb event actually cause a number of deaths, which we don't want to contemplate. It could still cause problems here, even if we have access to air conditioning, if we have people who don't have access to it. And so as we contemplate the world that is warmer, we should think about in our plans, how are we going to take care of people, especially older folks, who are particularly vulnerable to this, if they don't have access to air conditioning. All right, now, one that we probably don't have to worry about too much is sea level. Sea level is going to be a serious threat in large portions of the world. However, Connecticut is probably not one of them, except for any storms that have a large storm surge. And there, we would have at least a little protection hiding here behind Long Island to some degree. Hurricanes will push the water ahead of them, and now water will go up on land. One thing we have to realize that as climate change traps heat in our atmosphere, 93% of the heat goes into the ocean. And that's also physics, and something that you could experiment with in your own kitchen. That extra heat going into the oceans means that oceans are going to get deeper, or the sea level is going to get higher because you're warming the ocean and the water's taking up more volume. Okay? It's also going to make those storms stronger, the storms that get their energy from that heat. And so that's going to be an issue in many parts of the world, less so here. Another thing that the extra heat in the ocean is going to do is it's going to accelerate the melting of ice in the Arctic and subarctic, in the Antarctic. This is important because as the world warms, the Arctic ice will become lesser in extent. You will have more solar radiation will be absorbed in the water than reflected off the snow because there'll be less snow and ice there. The albedo of the area will be lessened. It's the term for reflect. A surface, its ability to reflect or scatter light is albedo. And so it's a self-reinforcing loop. The warmer the water, the more the ice melts. The more the ice melts, the less albedo there is. The less albedo, the more the ocean's warm. And so around it goes. Okay, I tell my students, and this is in all seriousness, that by the time they're my age, you'll be able to take a boat to the North Pole in the summertime. Maybe not every year, but you'll start being able to do that. And that's not good news. because of the change in albedo as we melt the ice and replace it with water. We're going from 80% reflective to 8% reflective and 92% absorbing. The last piece of the last ice age is Greenland, and to a lesser extent Western Australia. There's a area of there's an island in the North Atlantic called Greenland, and it has a very thick layer of ice on it. 16,000 years ago, at the beginning of the end of the last ice age, that kind of ice was present where we are now here in Connecticut, but it melted. We're further south, and Greenland, however, is melting along the edges. There's people living there, of course, and what we see is that industrialization and agriculture put dust and soot in the air, which settles out on the white surface of the ice of Greenland, making it less reflective, causing it to melt even faster. So it is it's a danger for the world going forward as well. Antarctica is the biggest ice area, ice cube. The western part, arbitrarily defined, because if you're staying at the South Pole, what's west, right? The western part is near the water, so it is more sensitive to the warming of the Antarctic oceans, and it is a lot of it contains ice shelves which are extending out over the ocean and gradually melting and not so gradually melting. And there's a couple of ice sheets that are showing a possibility of signs of breaking up. And if they were to break up, that's about 20-25 feet of sea level rise right there. So that's a concern. It's the Thwaites Glacier and the Pine Island Glacier in the western part of Antarctica. And the weather, as we've seen, has been kind of crazy, and talking about chaotic. You just last year in March of 2022, there was a heat dome that formed over eastern Antarctica, which is the cold part that's at high elevation. And it was crazy warm for Antarctica. I mean, temperatures at the surface of Antarctica, of the surface of the ice, that were well above freezing, which is just unprecedented. Well, sea level rise is going to be an issue if you live in Miami Beach, Florida, and other places like Bangladesh. The state of Connecticut, in their emergency planning, expects a sea level rise, or planning for a maximum sea level rise of about 1.5 meters, 4.5 feet, a maximum, okay, over, and I'm not sure, several decades anyway. Danbury is at 121 meters, and so we should be plenty safe from sea level rise, okay, if not from storm surge. And so sea level rise, as Bangladesh and Chesapeake Bay and Shanghai have to consider, it is not too much of an issue here, too much of a worry here. However, flooding is. Maybe some of you were around here in 1955. I was not yet on the world, and my parents were living. They hadn't even met yet, I don't think. But 1955 wasn't that long ago, and there was the quote unquote Great Flood of 1955. And it was caused by two hurricanes that tracked very close together, Diane and Connie, and they passed over Connecticut about, let's see, from the end of one to the beginning of the other was just a couple of days. And Hurricane Connie dumped rainfall in the area that's colored here on the western, the yellows and greens in the western part of Connecticut. They flooded, they began the flooding of the Housatonic River Basin and so on. But what Connie really did which if she had not been followed by another big hurricane right after, wouldn't have seemed so bad. And that is that she saturated the soil. You have all that rain saturating the soil, and once the little pores inside the soil are filled up, more rain doesn't go into the soil, it runs over the top, and it runs off into local creeks and rivers, and the Still River was bank overflow and all that. So Hurricane Connie was past us August 14th, and then here comes Diane on August 17th. And you can see where she precipitated in some of an overlapping area with Connie and a fair bit of Massachusetts, but upstream in some of the big watersheds that we have, Housatonic and the Connecticut watersheds. And you put it all together, and this was the rainfall accumulation of the two together. And so let's say Litchfield looks like 22 inches, almost 2 feet of rain over the course of what, a week. Must have been something, and it wouldn't have seemed so much had they not come one right after the other. Okay. And so anything downstream, of course, then was caught the water from the flood stage. And the Housatonic River was 18.6 feet of flood, and the Connecticut River was over 30. I'm not sure what Connecticut town this was. It might be Litchfield, it might be parts of Waterbury, but you know, it probably would have been a pretty exciting kayaking down the main street in those days. I'm sure it was a terrible, stressful time for all the people that were living in the area. Man, look at that. And that is just from 2 hurricanes that just happened to track one right after the other. Neither of them were unusual by themselves. All right, so that's where our flood could be coming from when we have some in the future. It could be that sort of situation where hurricanes line up. One thing that we are likely to see is more vectored and infectious diseases. What we have is increasing in temperature and warmth, allowing new vectors, the organisms that carry diseases like ticks and mosquitoes, to move into our area, ones that will carry diseases which we are not expecting, we don't have now. In infectious diseases, well, we've had our recent experiments with COVID, and that is an infectious disease. Some of the disease-causing organisms will have sensitivity to what's going on in the climate as well, including Plasmodium, the one that causes malaria, and others. Now, I have to remember that COVID, as most of the influenzas are zoonoses. Oops, sorry about that. Zoonoses, which means that they are disease that jump from one animal to another. We tend to get diseases from farm animals, pigs and chickens and ducks and whatnot, cows. Smallpox was a zoonosis. The 1918 influenza was a zoonosis as well, that was tied in with a really bad bacterial pneumonia. And so you put the two together, and the 1918 influenza killed young people, which is unusual for a influenza. The flu usually gets the very youngest and the very old, but not that one. It affected the teens and 20s in the population. But COVID is a zoonosis. As the human population grows and we move into areas previously which were just wildlife habitat, we're going to come in contact with those animals, and those animals could very well have diseases which can jump to us in some fashion. And there are lots and lots and lots of examples of that. So we have to be aware of that. We also have vectors that are likely to move in. The mosquitoes that carry yellow fever, which was once here, and malaria, and also some things that we haven't had here before: Eastern equine encephalitis, West Nile virus, Zika, and dengue. That's not a good idea. Ticks. There are, after all, we're used to Lyme. Lyme was named after a town in Connecticut. But there are new species of ticks, new to us, that are moving in because the climate has changed and they are more at home here now. And they are ones that will be warm and that like the warm and wet. And some of them will carry diseases that we're not familiar with: babesiosis and powassan, which is a virus; anaplasmosis, ehrlichiosis, Rocky Mountain spotted fever, and others as well. And so one of the effects of climate change that we need to have a heads up for is the likelihood that we'll have new diseases that we don't have now. Refugees. Even though we may not have many refugees from Connecticut, we are very likely to have refugees to Connecticut. Climate refugees are not a new thing in this country. Back in the 30s, you may remember the stories, or you read the book of the Dust Bowl. Those people moved into an area that was, at the time, was wetter than the long-term average, and they planted wheat at the encouragement of people who were selling the land. And then the climate of the area reverted back to its average, its long-term average, and suddenly wheat wasn't growing and everything was drying out. And then the winds blew and blew dust storms all the way to Washington, D.C. and New York. A lot of those folks that had invested their life savings in those wheat farms got up and went west, hearing that there were jobs in California. What were those people? What were the Dust Bowl Lokies, if not climate refugees? And that includes my great uncle Thurbert and my great uncle Cecil. Honest to God, that was their names. They moved from northeastern Oklahoma and southwest Missouri, where my grandfather stayed, and they were able to manage and get to California and make a life for themselves out there. But a lot of other people had much harder times. We can expect refugees. We can expect Americans as refugees from changes of climate. We can expect refugees from countries where so many of the people are inches from sea level and not loaded with resources to easily weather those conditions. This is Bangladesh. There are 16 million people living within a meter of sea level in the southern part of Bangladesh. Where are they going to go? And there's all our compatriots along the Gulf Coast. So the future of humanity, and this is not an exaggeration at all. In fact, it's probably an understatement. Our future will include hundreds of millions of climate refugees. Climate anxiety is something that I'm starting to see among college students, the young who are growing up knowing more and understanding more about, what climate change is and its long-term effects. They are telling me, because I listen to them and I ask them about this stuff, they're telling me that they're coming to college wondering whether it was worth their while. Should they spend all that money to get educated if the world's going to turn into Oklahoma, right? And during the Dust Bowl or whatever, okay? Should they have children? This is real anxiety to them in a way that it's not to people of my age, who kind of see as, well, I've kind of got through my life and I've just got a little bit left. So, but to them, it's their whole future. And this is increasing every year. In fact, a clinical psychologist was quoted who specializes in climate anxiety, saying many young people are experiencing grief and frustration, anxiety, and elements of betrayal by adults and other generations. Okay. Now, I mean, there's a certain amount of that which seems to be typical of the young, but it's different now. All right, I think I just said all this. Okay. Now, I suggest that the answer to that is in a couple of very old ideas. One of them is the 7-generation ethic. The notion that we as a society, we as individuals, should make our decisions about what we do in the future based on what is best, as best we know, for 7 generations in the future. This is a Native American ethic that the Iroquois are most famous for, although there are probably others that adopted something like it. The notion that you think about the future and all those generations ahead in making our decisions. The other one the other one is the greatest ethical concept the humans have ever come with, and that is, treat people the way you want to be treated, and that must not only deal with people that are next door, your annoying neighbors next door if they're annoying, but also people that live in other parts of the planet who you don't know yet, or maybe never will know, or people you expect to live after you're gone, and do to them as we would have hoped that others would do to us. Not to be too moralistic, I'm not a preacher, but I think that is what must motivate us going forward if we want our 7 generations to see us as being useful. Carl Sagan, the famous astronomer, in his first time he spoke to Congress, says we all live in the same greenhouse, which is a pretty pithy way of phrasing it, I think. And I argue, I'm an educator, so education seems to be a big thing, is my big thing, and that's why I'm here. I would argue for the need for climate education for everyone from kids on up, and that includes you all, and I'm glad you came. Because as I always tell people, especially older folks, I have a grandson, so I can say this: what is best for our grandchildren is what's best for us. And that's what I have to say, and I'd be glad to answer some questions. If I don't know the answer, I'll tell you I don't know.
Awesome. If anyone has any questions, please type it in the chat. I will relay it to Dr. Mitch. Thank you for your presentation. It was really good.
You're welcome. Happy to do it.
So we'll give some folks some time if they want to ask Dr. Mitch Wagener a few questions.
Oh, there's one in the chat. Very interesting. Thank you. Oh, thank you for coming.
Just know, or just real quick, the next presentation that we have is February 27th. It's a Monday, and it is what is a civilization and how do we save ours? So that's the next one that is coming up. So if you can, I think you'll be able to register for that. If not tomorrow, the following week. So please spread the word. This is a great series that we have here. You have a question?
That particular civilization, I'm hoping to start a conversation. I would like you all to express your opinions, and we can all discuss it as as part of the end of that particular talk.
That's a great suggestion. I think that also is something that we may want to do for your talks that we're going to try to schedule here in the Maker Lab. We're planning on some stuff So, stay tuned, folks, but that will be a great sort of opportunity for folks to be here in person with Dr. Mitch Wagener, and we can go a little bit farther in that conversation with that. So we have.
Here's a question. Can I answer this one?
Yeah, go ahead. Go ahead.
There's one from Ron Geck. Thank you for the question. Everything in the world is always changing. Why is climate change any different? Well, things are changing all the time. The changes that have, in fact, there were times in Earth's history where the temperatures were much colder at certain times and much warmer at others. That's very true. What we are seeing now, those changes were not part of human history. We did not suffer from them because by and large, we weren't around for most of it, although we were for parts of the last ice age. But we weren't involved in causing it or stopping it or anything. What we're seeing now are changes that are happening much, much faster than they would happen under natural conditions. What brings our world out of a cold temperature into a warm one is something called the Milankovitch cycles that have to do with the shape of the orbit of the Earth around the sun and the wobble of the Earth and things like that. And all those things change over tens of thousands of years. What we have done in increasing the heat as we've done that in just the last 200 years since the Industrial Revolution. So we are sped it up greatly to such a point that it is a danger to us and to our grandchildren. That's why I'm talking about it. But it's a good question. I hear it a fair bit.
We have a question from Anita, and this is something I just saw from a friend of mine on Twitter who said the same thing. I always look forward to March and the arrival of spring bulbs, but they are happening. Green shoots poking up now in January. Is this the new BAU for us in Danbury? It's also from a friend of mine in Meriden, Connecticut. He is noticing daffodils sprouting up in his area. So any comment on that, Dr. Mitch?
There are certainly year-to-year variations. Okay, some years are going to be cooler than average. Some of them are going to be warmer. The bulbs are going to respond to, the fact that we haven't had a lot of cold weather, except for that little snap right around Christmas. And I guess we have a day of cold weather coming up next week. And so they have accumulated the warmth that would happen in spring earlier. And so they are popping up. Now, if we continue on the way we are, they'll just probably grow slowly and they'll be none the worse. If on the other hand, we have a week of really bitter cold, it might be harder on them. I don't know. So there's a combination of the natural variation that we see all the time, and superimposed over that is the trend we are seeing because of the increase of greenhouse gases in the atmosphere.
Excellent explanation. Do we have any other questions before we call it an evening? I guess not. So thanks everyone for joining us this evening. On behalf of the Friends of the Danbury Library, we thank Dr. Mitch Wagener of the Western Connecticut State University, and we look forward to your next presentation next February, February 27th. It's a Monday. So please look out for that, everyone.
May I plug the Jane Goodall Talks real quick?
Certainly, go ahead.
Starting after our spring break, which is middle of March, we'll have a series of talks on campus, and I'll make sure that Aurelio has that information so he can share it. And they will be in the evening at 7 o'clock in the Science Building. And each Wednesday, one of our faculty for 5 weeks will be giving a talk, different faculty every week, in conjunction with one of the students. And this year we have a sociologist, a chemist, and 3 biologists. It's just the way it worked out. But you'll be able to hear about this stuff from the point of view of the other faculty, not just me.
Excellent.
Although I'm doing it last week.
And once you give me the information, I will certainly forward that to everyone who registered this evening. The link to the schedule, as well as a link to the YouTube video of this presentation for those of us who could not join us this evening. Once again, on behalf of the Danbury Library, my name is Aurelio Muraca. Thank you for joining us, and thank you, Dr. Mitch. Until next time, have a good evening.
See you all next time.
Bye-bye.